Okay, so I thought I'd do a video on a technique that there's a handful of videos on YouTube, but some of them are out of date or a little questionable. So this is process going in and taking 3D printed parts or any plastic part in general and metal plating it. So I'm using a nickel-based solution here, AR 841 AR. Let me get the card here so it's a little easier to see the name. You can get it on Amazon, eBay, handful of other places. A little expensive. It's about $30 a jar, and it's not a lot you get in there. And it is pretty much a consumable item that once you crack it open, start using it, you probably want to use it in a few months. I had one other jar after about 4 months. It dried out on me, and I didn't use it all up, which was a bummer. But part I'm working on for a customer, taking 3D printed giraffe heads. These are intended to be doorknobs for on a cabinet door, cupboard door, something like that. And they're designed, there's a pair of them. They sit at an angle because the person wants the base of them to be pretty close together, but then flare out away from each other at the top. So, that's what they get. And I'm going in metal plating this, so I have to paint it in a nickel brush-on solution. Bites into the plastic, and after it cures, it becomes conductive. Take you over to my other bench and show you one of the ones that's painted. Let me pause this. Okay, so here's one of the ones that's already painted in the solution, and it's curing right now. You can give it depending on weather, like a good hour to cure. The ones I'm doing tonight, they're going to sit overnight. I'll put them on to do their thing in the morning. But if I take my continuity tester here, let's see if I can do this. I need more hands than I have. So it's highly conductive. Stuff works really great, and I haven't had any trouble with it I've only been using this stuff since April, beginning of April. Haven't had any trouble with it with the handful of stuff I've done. I'll show you one of the finished pieces that's already been plated. Okay, I had to run in the house and grab the ones I've already done. So these are ones that have already been copper plated. And since it's real copper, and due to some weird characteristics in the process, there on the ear, where it's kind of, that signs that the copper plating there, come on focus, signs that the copper plating there got too hot. And then I took some triple aught steel wool and was scrubbing at it a little, polishing it up some, checking some spots that I thought didn't take. Turned out they did. And these are about a day old, and I didn't get them quite cleaned up all the way, and you can see they're already got copper corrosion. So just show you it's real copper. So, and then if you are looking at this video because you're planning on doing copper plating yourself, some of the things that they don't show a whole lot, and I got my tank sitting over here in the corner, that my copper solution here, I'm using a vinegar salt solution. Regular distilled white vinegar. Any distilled vinegar, white vinegar will work. And then just regular table salt. There's really no good or rhyme or reason on the ratio of how much salt to put in there. You're mostly just putting in there for a little bit of conductivity. So if you're mixing up, let's see, I got 5 gallons here of copper sulfate solution I've made. So, yeah, probably tablespoon of salt, I think might be what I end up doing. A little hard to say. And I'm using a adjustable tabletop power supply, so I can adjust the voltage, the amps, and it also shows me a readout on there of what the volts are, the amps, the watts. So you're typically going to be looking around probably 3 volts. There is an actual formula on how much power that runs through the solution while plating for best plating, but you have to know the actual surface area to be able to calculate that correctly. And of course, you want to make sure you use a plastic container. You don't want to use a metal container. You could use a glass container. I went the plastic route here on this because I didn't want to deal with a glass item that big. You could use an old fish tank if you wanted, if you're doing big pieces. If you're doing big long pieces, you can use like plastic drain trough and just silicone caulk the caps on the ends, and you can do big long pieces then. Sky's the limit on what you're doing here. And then depending on the size of the piece, it might take 6-8 hours up to 48 hours. It just varies there on what you're doing. Can't see, you can kind of see it in there. I have a couple of air stones in here. Here's my air pump, dual line. Now it helps agitate the solution, just so that way, it's nice and bubbly stirring up in there. And you don't want bubbles to form on your plating, because you'll end up with a shitty plate job, and you'll be having to clean that off or start over. So you definitely want to avoid that. Bubbles will start forming if your voltage is getting too high. But if you're keeping the solution agitated and keeping the bubbles from forming on there, you can get by running it that high. That's certainly not a problem. You just have to be mindful of it. Because if you don't do something about the bubbles, then you'll end up with weird little circle spots over your plating. For my solution here, I'm using 4 pieces of copper water pipe and wires with alligator clips, clipping it all together. So that way I have a positive contact point in each corner. So if I'm doing something, let's see. So if I'm doing one of these guys in there and I actually have it hanging upside down, that makes it then basically all 4 corners of it are getting done. And you could certainly put more pipes in there and get better surface coverage. I mean, if you were to go in and take like the copper water pipe and elbows and kind of make like a cage in there coming down the corners and then around the bottoms, you could definitely do that. Just don't solder it together, because you don't want that contamination in there. The only metal you want in there to keep from contaminating it is going to be your copper. I know with copper water pipe there's some impurities in there, but the impurities are so low it doesn't seem to matter. You don't want to be trying to copper plate something and have lead solder or a piece of steel in there. You can end up really mucking things up. I learned that lesson. Let's see. Oh yeah. So positive on your sacrificial metal, the pieces of copper water pipe. Negative will go on the item you're plating, because you want the positive to remove metal and go to negative depositing the metal. So very important. If you goop and put it the other way around, well, no plating will happen to this. And say like it's a item that you already plated, but you decide you want to put more material on it, and you goof and somehow reverse the power leads, and instead of this being negative, now it's positive, you'll remove your material off of it and possibly ruin your part. Now, that is a cleaning process you can intentionally do to some items, but that's a story for another time. So, guess if somebody comes across this video, has a question about this process, feel free to hit me up. I will try to respond back to this video. And I'll see if I can leave some more information and maybe some links if I end up posting this anywhere. If I do, it'll be on my YouTube and probably a few other places. All right. Have a good day.